2.4, 2.5 are just other ways to graph lines. That's all we're going to be pretty much doing. So last time we did a T-chart, right? So essentially like this, plug numbers in, make the line, and we're done. So that's one way. And I think that's the most simplest of the ways to do it, okay? But like in math, right, there's always one way. So if you don't like one way, well, guess what? There's other ways. And hopefully you like those, right, to get comfortable with them when it comes to it. And that's kind of be the theme of this entire semester. There's multiple ways to do stuff, especially when you get to chapters 5 and 6, you'll see like there's actually 7 different ways to solve for a couple of things, which is, pretty crazy. People are just so bored they can figure out how to do some stuff, and things like that. So let's start 2.4, linear functions. So in this section, we're going to graph functions using, again, a different ways to do it. So the first one we're going to do is when it comes to something called the slope, okay, or the X intercept. Well, first we'll talk about something called the X and Y intercepts. Okay, so the X intercept is of the form 0, y. So in other words, there's always a 0 for the X and there's something for the Y. So in other words, we plug in 0 for X and then we go forwards when it comes to it. The Y-intercept, actually, did I flip these around? Oh, no, yeah, these are flipped around. This is an X, this is a Y. Go ahead and just write those out for me. So change that to a Y, change this to an X. There we go. That makes way more sense now. The Y-intercept is of the form 0, y, and the X-intercept is of the form X, 0. Okay. There we go. So now, in other words, we're just going to plug in 0 for the respect value and see what we get for the other one. Okay. Now, one of these are easy, and the other one is just a little bit more difficult, but is again not too difficult. Okay. So here's an example. So we want to find the X and Y intercepts of the function. Okay. So first, let's find the Y-intercept. I'm just going to, instead of X, it's the Y-intercept. So what that means is I'm going to plug in 0 in for X. So, hey, just like your quiz, right? Just plug in 0 in for X. So plug it in. So that gives me 0. 0 minus 9 is just -9. So now my Y-intercept is the point 0, -9. Okay, again, in that form there. Okay. And now the X-intercept is just the opposite. Now we're going to plug in 0 in for Y and see what we get for the X. So this one's a little bit more complicated because we're going to set this whole thing equal to 0. And then just solve for X like the first day of class, right? Just, so we're going to add 9 to both sides and then divide by -3. And we get X equals -3. So therefore our X-intercept is -3, 0, right? Again, in that same template there. Okay. Now, this is the same process if you just do a T-chart, believe it or not. All we're going to do is we're plugging in these numbers respectively and then seeing what those are going to be the outputs themselves. So in most cases, you're probably going to get the X and Y intercepts as you do the T-chart if you actually get lucky. If you actually plug in 0, you'll get that one out essentially. That's pretty much how we're going to find the X intercepts of these concepts when it comes to it. Okay. So before we go any further, let's try another example so you guys can get a little bit more comfortable with that. So let's suppose now we have Y equals 3x plus 10, for instance. Okay. And same process, we will find a Y and X intercepts respectively. Okay. So let's just do the easy one. So we're going to plug in 0 in for X and see what we get out for Y. So I'm just going to plug in 0 in for X. Well, that goes out. So Y equals 10. So our Y-intercept is 0, 10. And now we do the same thing now for the X. So the X, I'm just going to swap places. So I'm going to plug in 0 in for Y, and we're going to figure out what X is. So now this time it's going to be Y equals 3x plus 10. And again, like I said, this one's a little bit more work because you actually have to solve for it. The other one is just plug in and see what we get out. So subtract 10 and then dividing by 3, we get 10 over 3. So this is our x-intercept there. So negative 10 over 3, comma 0. Now, here's a very important thing. When it comes to X and Y intercepts, it's not just a number. It's an actual point on the line, meaning you can graph them, right? So hint for your exam and for your homework, when they ask you for the X and Y intercepts, you have to give me a point. Okay, so not just don't give me like X equals this, Y equals that. You have to give me the actual points, right? So including the zeros and everything. So, fun fact there as well. Okay. Any questions there at all? No? All good? And we'll graph them in a little bit. Just want to give you guys a little rundown of how to do them. So when it comes to it. Okay, so no one says anything, so I'm assuming all good then. Okay. All right. So speaking of that kind of concept, now we're going to talk about something called horizontal and vertical lines. Okay. So a horizontal line looks like this, and a vertical line looks like that. Okay. Now, the whole point of these intercepts is an intercept is where it crosses its respective axis, right? So remember, this is the y-axis and this is the x-axis, right? So notice this line will never cross the x-axis, right? This is the x, this is the y. So therefore, when it comes to horizontal lines, this has no x-intercept, because again, it never crosses the x-axis. However, when it comes to vertical lines, it's just the opposite. So notice this one's going up and down, so this never crosses the y-axis at all. So really, this one has no y-intercept. So a fun fact, like say for a homework question or hint in for an exam question, I can say, okay, what are lines that have no x-intercepts? And automatically it has to be horizontal, right? So in that case, there's literally no math involved, right? You never have to solve for anything. It's just a concept question when it comes to it. Or I can say, what are lines that have no y-intercept? And therefore that would be vertical lines, because again, they do not touch the y-axis. Okay. So we'll talk about more about horizontal and vertical, but this is one major concept for each individual case there. Okay. And of course, right, they have a y-intercept, right? This one touches it there. This one has an x-intercept, touches it there. But, the main focus is they only have one, not two of them. So lines usually have, both an x and y-intercept. If they don't have one or the other, it's going to be this type of situation here when it comes to it. Okay. All right. Any questions on that at all? No? Easy peasy? Okay, cool. All right, in that case, now let's actually talk about something else when it comes to it, slope. So slope is a major part of graphing and math in general, believe it or not, when it comes to it. So slope is an easy concept, right? So I'm pretty sure everybody's seen a roller coaster, has been on a roller coaster. So if you're scared of roller coasters, at least you've seen one, right? So usually you have stuff like this, and it goes up and down, like the old school roller coasters, right? Not the crazy ones like they have at Six Flags, but the old school ones just go up, 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 right? And when it comes to slope, it's the same. Oh, man, come on, focus. See if I tweak it again, it wouldn't focus. Okay, cool. Now I know how to focus it. So slope essentially tells you is how fast you're going up or how fast you're going down. That's literally what slope represents. Okay, it's just how the actual formal one says the slope of a line is how steep the line is going up, down, or constant throughout the line itself. But essentially is, you know, how fast are you going up, how fast you're going down, or how fast you're going flat across when it comes to it. Again, the best thing I could think of it is just think of a roller coaster, right? Going up and down when it comes to it. Okay? So that's essentially what we'd be looking for. Like given a line, right, just going this way, for instance, how fast is it going up? Or, you know, when it comes to, or if it's going the opposite, how fast are you going down when it comes to, again, and if you're constant, how fast are you going from left to right? Okay? Now, there's two ways to find slope, and the two ways depends on what's given to you, believe it or not. Okay? So the first way is something called the rise over run. Okay? So you use this way when you're given a graph. You want to pick 2 points on the graph, and then you go to something called rise. That means going up or down, and then you're going to go run, meaning you're just going to go straight across. Okay? Now, when it comes to rise, so up or down, meaning you're going to go see if you're going this way or that way. So that way means by running or rising. And when it comes to running, you're always going to be going this way, just to make it easier for yourself. Okay. So, for example, let's suppose we have this line here. That line right there. See how close I can get to this there. And we want to find the slope of this line using this rise over run method. Okay. So how we're going to do is we're going to pick any 2 points on this line, and you can pick any 2 points you want. Okay. Now, in your homework, in most cases, they'll identify those points for you. They'll circulate. You may want to use that point or like this point, you know, when it comes to it. So we'll just use those points, just like your homework will ask you. Okay. And what we want to do is we're going to see how much we're going up or down. So starting from this point, again, just like a checkers, you have to go only up, only down, no diagonal, it's just up or down. So I want to figure out, so I want to go up to here. So I'm going to make a line there. And I'm going to count how much I go up to meet this point here. So starting here, I go up 2 units. So right, I went up 2 units. Okay. And since we went up 2 units, that's going to be the top number. That's our rising. So when it comes to our slope, so we went up by 2 units. And then we're going to running, how much are we going to go to the right-hand side is going to be the bottom number, hence the run. So starting here, I just count 1, 2, 3, 4, 5, 6. So it's over 6. Again, how to count the 6? Well, how to go? So it's 1, 2, right? Just going down here. 3, 4, 5, 6 spaces. How do we go up? Well, that goes up 1 space, 2 spaces, right? So kind of think of like your floor as you can only go left and right. And if I tell you, okay, move 2 spaces to your right. So you go count 1, 2 steps. Now go up by 5. Okay, go up by 5. So you can only go in up and down and to the right. You can never go diagonal when it comes to it. Okay. And at this point, you can simplify this to be 1/3, and that is your slope. So that's how fast this line is going from here to here. Again, from any point when it comes to it. It's going 1/3, let's say, speed, if you want to think of it that way. Okay. Any questions on this first example here? No? Very comfortable? Okay. All right, so let's just do one more before we go further so you guys can see the difference. So you may need to draw this one on there, but still not too bad. So let's suppose we have this one now. I'll give you a quick minute to draw it out. So everybody got it down? A little quick sketch. Okay. Okay. So now we do the same thing, right? Now the key thing is you always run, you always rise first. You're either going up or down. Never do the bottom, always go up or down first. So notice, in order to get to this point, from here to there, I have to go down, right? So it's not going up anymore. I have to go down. So again, the same process is I want to see where they intersect. So I'm just going to make a line this way and a line that way. So there we go. So that's how much I'm rising, or in this case, going down. So I got to count how many units I'm going down from here to there. And again, just count 1, 2. So now since I went down, I have to put a -2 because I'm going down instead. And now the same process goes across. How much am I going always to the right-hand side? And again, I just count 1, 2, 3. This is now 3 units to the right. So our slope is going to be -2 over 3. So this is how fast you're going down this time, right? And the reason why it's negative is because you're going down. So positive slopes mean you're going up. Negative slopes mean you're going down.
And same rule applies, right? We're always going to read from left to right.
Correct. So rise, when you come to running, you're always moving to the right-hand side to make it easier for you. Yeah. Yeah, I know some teachers, I don't know if you guys are in high school or stuff like that, taught you different ways to do it this way. I always like to do up or down first. That way you don't get confused with that negative. So the negative will tell you you're going up or down, and you always go to the right to help you out when it comes to it. And again, you can pick any point. So I could have picked this point here, and let's say, this point here. And I would, if I do the exact same thing, and if I simplify, right? Once I simplify, I would get this back out. Just like here, 2 over 6 simplifies to 1/3, right? So if I did the exact same process, I probably get, I don't know, like 6 over 9. But if you simplify, you will get the same fraction. That's the key thing, okay? So once you simplify it, you'll have the exact same ones, no matter what points you actually choose when it comes to it. So any other questions on using rise over run at all? No? Everybody good? Okay. So, like I said, let's suppose you really don't like that. I hate graphing. Oh God, when it comes to it. Well, guess what? There's another way to find slope. And it's using more math, right, when it comes to it. So this is kind of like considered geometry because you're just doing geometric stuff. But when it comes to the algebra portion, given 2 points, x1, y1, and x2, y2. So in other words, just literally given 2 points here like this. You can find the slope by using this equation right here. It's pretty famous, right, when it comes to it. So it's the change of y. So it's really like the change of y over the change of x. I'm pretty sure you guys kind of heard that before. It means you subtract the y values and you divide by the subtraction of the x values. Okay? And that gives you the exact same slope if you would just use rise over run, or just use this to find the slope. Okay? So if you're more of a visual person, you may like this stuff. If you're more of a, not a visual person, you like to do stuff with your hands, you may want to use the equation. But again, there's 2 different ways now to find slope, depending on your own preference when it comes to it. Okay? So how do we do this, right? So same process here when it comes to when we did the distance formula and also the midpoint formula. All we do is put in the values where they're supposed to be, right? So let's suppose we want to find the slope of these 2 points here. Okay. So therefore, I just abbreviate this as x1, that's y1. This is x2, y2, just like we did for the midpoint formula and also the distance form, right? Just evaluate each one accordingly, and then we just plug it in. So the first equation is y2, so 0 minus y1, so 0 minus 7, divided by x2, which is 2, minus x1, which is negative 3. So again, you just got to be careful because these negatives actually cancel away where you get a plus. So on the top is just negative 7, and on the bottom it's 2 plus 3 because of those minuses to cancel away, and you just get 5. So your slope is negative 7 over 5. And now, since knowing that means a negative means you're going down and a positive means you're going up, I can also ask you, okay, is this line going up or down? And you would say this one is down because it's a negative. So literally, without even drawing it, now you know that concept when it comes to it. Or I can say, is it increasing or decreasing? Because that's the same thing as going up or down, right? So this would be decreasing. So the whole line is going down, so just decreasing altogether. Right, so all those concepts come into play just by knowing one single number. And that's why slope is so important when it comes to mathematics. It gives you a lot of information. Okay. So now let's actually put into play, right? So we have 3 examples here. So let's do our equation to find the slope of each individual case. Okay. So same process here. Well, x1, y1, x2, y2. So our slope is going to be y2, so 9 minus 9 over negative 7 minus negative 3. Okay. So simplifying this, that gives me 0 on top. And again, these gives me a positive. So this actually is negative 7 plus 3, so that's a negative 4. All right, here's a fun little fact. What's our answer? You can either shout it out or type in the chat. Yep, it is a big fat 0. So 0 over any number is automatically 0. Okay. So all that work just for 0. Oh, that sucks, right? And now, like I said, right, we talked about increasing, decreasing. Go ahead.
So would the point be 0, 0 then?
No. So remember, a slope is just telling you how fast you're going up or down, or constant.
So then that would be constant.
So a constant, yeah. And we're actually talking about that in a little bit when it comes to slopes. But yeah, so that's a precursor. So you're pretty much going nowhere, which is a funny thing, right? When it comes to it, yeah. Any other questions on our first example so far? Okay, let's keep going. So let's try B and C. So just in case you guys go ahead, we're going to change this 9 into a 10 because I don't want to get another 0. So for this one, let's just do this one. So this is x1, y1, x2, y2. So our slope is going to be 6 minus 4 over 10 minus, again, a negative 12. Right, so just don't forget about your negatives. So 6 minus 4 is 2. And now this becomes positive, so it's going to be 10 plus 12, right, this time. And that's going to be 22. So if I simplify this, in other words, divide both by 2, we get a slope of 1 over 11. So we're not going really fast, but, you know, still trucking along when it comes to it, right? So, for instance, in this case, since we have a slope of 1 over 11, is it going up or down? So in other words, is it looking like this or looking like that? Yep, going up. Now, I can also say, instead of going up or down, is it increasing or decreasing?
Increase.
Yep, and this will be increasing. Because remember, up and down is the same as increasing, decreasing, right? Increasing is going up, decreasing means you're going down. Right? So same concept. It's just fancier term, right? Since we're in college algebra when it comes to it. Okay. So any questions on part B? Not too bad. Okay, so in that case, I'll give you guys a quick minute or two to do C. Here's your extra credit, first extra credit for today. So I'll give you guys a quick minute or two, go for it. And once you're finished, just type it in the chat. Give you guys another 30 seconds if you haven't done it. Okay, so let's see. So x1, y1, x2, y2. So slope is 9 minus 10 over 5 minus a negative 8. And it looks like a lot of you guys got it. That's going to be negative 1. It's being plus. So there you go. Good. And a couple of you guys did it. Yep, so it's down, so it'll be decreasing.